Assalamu alaikum class. This is summary for paper 1, your mathematics. And the study you have Mr. Bamba Muhammad. So today we are seeing integration. Like last time we looked at integration, and basically it was mobilizing a function and this derivative. This time we are looking at the same topic on the capability to address ourselves basically on the functions. And today we are looking at integration of all the powers of sin x and cos x. Integration of all the powers of sin x and cos x. So basically, when we begin a chapter, there must always be a principle to follow. And the principle is one which governs the whole chapter. And my teaching, as you have always observed, I normally give you the principle. If you get the principle, it means you have got to whatever it takes to understand that chapter. So when we talk about integration or integrating all the powers of sin x and cos x, we are addressing ourselves to the functions, basically sin and cos. We are now noting the concept before even beginning, so that what we are going to handle as far as this topic is concerned, as far as integration of sin x and cos x is concerned, it will be a guiding principle. And the guiding principle, we might claim that if you have to integrate an order power of sin and cos, you use Pythagoras theorem. That is the main concept. I repeat, if we have to integrate sin x and cos x, and basically we can integrate the order power of sin x, cos x with Pythagoras theorem. What is Pythagoras theorem? As far as calculation is concerned, Pythagoras theorem is basically the identity, number one. Our first identity we had in trigonometry is called Pythagoras theorem. And that is cos squared x plus sin squared x is equal to 1. That's what we call Pythagoras theorem. Which means, if you are going to integrate sin to power 3, sin to power 5, those are all the powers, sin to power 7, we shall be using Pythagoras theorem. If you are going to integrate cos power 3, cos power 5, cos power 7, so long as the power is an odd power, we shall be using Pythagoras theorem. Example number 1. Example 1. How do we apply Pythagoras theorem to all the powers of sin and cos? Integrate sin to power 3 x dx. Check the power, class. This is an onward power. Check the power is an odd, and we are saying if you have to integrate an odd power, use Pythagoras theorem. So it means it is a taboo to handle all the powers. So what we do, we automatically change the power 3 in terms of power 2. Because Pythagoras theorem is to power 2. Pythagoras theorem is to power 2. Which means this is the same as integral of sine squared x. Sine x dx. And to observe, this is power 3. Now, I'm interpreting the same figuration. But sine power 3x is the same as sine squared x, sine x dx. This will give us sine power 3. So since now I have sine squared x, and Pythagoras is to that power, sine squared x is here, I can make it the subject from this identity. And that gives us 1 minus cos squared x sin x. We are substituting for only sin squared x here, using the first identity. Make it the subject. It is going to be 1 minus cos squared x, which is Pythagoras theorem. And this is the Pythagoras I was referring to. So at this point, after changing Pythagoras theorem, it becomes easier for us to interpret now this. How? I want to go to Zavant and get the concept. How did about this? In the integration of the sine and cos, this is a point to note. In the integration of sine and cos, if you have cos and sine as a product, the TB ratio with the highest power becomes a function. The TB ratio with the highest power becomes a function. And this is the product of sine and cos squared, which means cos squared and sine x, cos becomes a function. So long as it is a product of sine and cos, the one with the highest power takes it all, becomes the boss. And here our boss is cos x. Why? Cos x to the power 2, sin x to the power 1. And therefore, our cos becomes a function, and the sine becomes a derivative. It takes us back to our first topic. Recognizing a function and its derivative. Now, as far as trig is concerned, or trig ratios are concerned, we are claiming that so long as there is a product of sine and cos, we just need to observe of the two, sine and cos, which one owned, which one has the highest index, which one has the highest power. The one with the highest power becomes the function. The one with the least power becomes the derivative. And remember, after identifying a function, after identifying a function, our function becomes the boss. Becomes the boss. So the moment you identify the function, then it becomes what? The boss. And therefore, our concentration now will be on the function. And the derivative becomes a minor. Becomes a minor. Therefore, cos squared x times sin x. Since cos has the highest power, then cos is the function. And that is what now relates to be equal to the function. So our rating must be for the function. So since cos Or is the highest power? It is the function. And sin x is the derivative. So the derivative is the minor, just ignore the derivative, and the u will go in for the function which is cos x. Next, what do we do? After identifying the function which is our cos, we are letting any variable of your own choice, which is u, equal to the function. And from that point, we must differentiate to get the u, the x. Where the x? We are expecting x. Okay? We are expecting x. So differentiating cos x, this is a part, this is a chapter of this one. We had differentiating cos x, you get negative sin x. Differentiating cos x, you get negative sin x. And therefore, from here, I must make sure that I come up with the x. Because I have it here. I have that the x there. So I'm going to have now the x making the subject. The x will be equal to negative du divided by sin x. We are making the x the subject from this step. Our dx is equal to negative du over sin x. Then we shall recall our principal equation, which is this one here. I have the x, and remember I have cos x as u. So I'm going to have now the integral of 1 minus my cos x is squared, but now cos x is u. So it becomes what? U squared into sin x. Sin x is a derivative. You don't substitute for it. Just substitute for the function and the respect, which is the x. So 1 minus u squared sin x times mind the x. Mind the x is equal to negative du divided by sin x. And class, this one is very, very possible now. That was going to cancel out. I'm going to remain with the negative integral 1 minus u squared du. So what does it mean? That we have now managed to change the variable from x into u. And if you can observe, we have transformed it from x to u. This is the respect to what? Which is the u. This is u squared. So at this level, I can now go ahead and integrate in terms of u. And this calls for the integration of 1 and the integration of u squared. This is the respect. So it becomes easier for us now to handle. And at the end of it all, it's going to give us a right answer. So this means maintaining the negative. We are removing this sign because integrating 1 gives us u. Because what is 1? What means u power 0? U power 0, which means increase the power by 1, is going to be u. Minus. The method demands that the power must be increased by 1, which means I'm going to increase the power by 1, and it's going to give us u power 3 divided by what? By 3. We raise the power by 1 over the raising power. Then we add a constant c. So long as the integration does not bear the limits, we must add a c. And this becomes our answer. But remember, The given equation was in terms of x. Now we have changed the numbers of u. So at the end of it all, I must take u back to x. And that gives us now negative. What is our u? Our u is from the negative. U is equal x. U is equal to x. And therefore I'm going to have negative u is negative cos x minus cos cubed x over 3. That's a constant c. But this is a minus becomes what? Plus here. This finally gives us negative cos x plus a third cos cubed x plus c. And that is the integral of sine power 3. The integral of sine power 3x. So if you have time, I normally encourage my students to conclude and say therefore the integral of sine power 3x, which is cubed x, the x is equal to negative cos x plus a third cos. That is the answer. Underline. That is the answer. Yeah, I know some of you know my examination in class. I'll try to go through just this one. Once again, I can get the concept before we go to the next example. So before we go to the second example, let us go through the first example very fast. Then I'll give the example number 2. The topic was about integration of figurations. And this time we are addressing ourselves to integration of all powers. Sin x and cos x. We are saying it is a taboo to integrate all the power. Now, what do? What we do is we use a concept which is very clear. And that concept is what we call as Pythagoras theorem. And what is Pythagoras theorem? Pythagoras theorem is simply the first identity in trigonometry, which is cos squared x plus sin squared what? X is equal to 1. This is called the Pythagoras theorem. Why do you call it Pythagoras? I want to call when we are deriving that equation. Who is Pythagoras theorem? As I end of it all is that name, Pythagoras what? Theorem. So it has been given an odd power. If I have been given sine raised to an odd power, for example, sine power 3 is an odd power. Sine power 1 is an odd power. Sine power 5. Sine whose power 7 etc. Cos power 3, cos power 5, cos power 7, these are all the powers. We use Pythagoras theorem. So it means our first of all I have my sin power 3x dx, where this means integrate, and this is respect. I must reduce this sine power 3 in terms of power 2. So this is sine squared x, sine x, which takes us back to the same thing. But what am I doing in this order? Pythagoras theorem is to power 2. That's why we are having sine squared. So at the end of it all, I must implement that principle by changing sine squared x in terms of Pythagoras theorem. And I'm using this identity. We are making sine squared x the subject. So cos has cos right hand side to become negative. Sine squared x is equal to 1 minus cos squared x. This is what I'm trying to substitute. Sine squared x is equal to this. then times sine x, which we have here, times our dx. Remember, for trig functions, basically cos and sine, in the moment you have a product of those two, sine and cos, the one with the highest power becomes the boss. The one with the highest power becomes the one with the least power becomes our derivative. And now discussion. The least power, basically we take it into B minor. So our attention must go for the function. So this one becomes a derivative because it has the least power. Our cos becomes a function because it has the highest power. And therefore, our substitution must go for the measure, which is the function. So we have identified the function and the derivative. The function is cos. The derivative is sine. Ignore the derivative. That's it like that. Take on the function. So our rating, as you agreed earlier, our function is now the major subject. So we shall now substitute for the function. So our rating must go in for the function, which is cos. So we shall say let u, this is just a value, represent a function which is cos x. Let u represent a function which is cos x. Then we will go ahead to get the derivative of the function, which means I must differentiate the function. And therefore, the u, the x, is equal to negative sine x. Remember, differentiating cos, you get negative sine. But differentiating the sine, you get a positive cos. Majority of you have this concept. I told you this concept, and I'm sure you're very comfortable with this. Differentiating cos, you get negative sine. So the u, the x, is negative sine x. We make the x the subject. The x is the subject. So our dx is equal to the negative du plus the x. Now you recall the main principal equation. It is where you apply the Pythagoras theorem. Where you apply Pythagoras theorem becomes the key principle. And therefore, our idea we get advanced to answer now this equation here. So my cos x is u. And therefore, we have a negative integral. This is the negative integral. The negative is as a result of the negative du over sine x. Negative integral 1 minus u squared. My cos x is u. And therefore, this becomes u squared. Times sine x, which is my derivative. Times dx, which is negative du over sine x. Negative du over sine what? X. That's what this is negative. The negative becomes a multiple of the whole equation. So I will have to bring out the negative out of the integral sign. So this is the negative, which is a result of what? Having x and negative du over sine x. So this means the sine x will not survive. And finally, we shall have that. The integral sign demands that you must integrate the function in the bracket. And integrating u1 gives us u. Why we get u? Integrating 1 means we are integrating u to power 0. du. But remember, this we must take the power by 1, so it is 0 plus 1. over 1, which gives us now u. So this gives us u. Interpolate u power 2, the power must be raised by 1 to give us u power 3, divided by the raised power of 3. Then you add a constant. But you must recall that at the beginning, we didn't have u. U was a variable to represent the function. So you must go back and recall what was my u. Formulating u is equal to, then you substitute for u. At the same time, we are opening the brackets, which have negative cos x plus a third cos power 3x plus c. You underline. That is the integrand which you get as a result of integrating sine power 3x dx. And that is an example. You can help you to work out so many examples and so many numbers. An example is very clear, and using that knowledge, I'm sure also you can work out cos power 3 now, dx, which is going to be our next example. But if you missed example number 1, you can have example 2. So example 2 will be in terms of cos, not sine this time, in terms of cos. Let us have now cos power 3. Cos power 3 integral of cos power 3x dx. Very simple question. Is this an odd power? The answer is yes. This is an odd power. And therefore, what's the concept? The concept you can recall, I think interpreting an even power, the concept is simple, with Pythagoras theorem. With Pythagoras theorem is simply for squared x plus sine what? Squared x is equal to, this square is equal to 1. So our constant now is going to be, we must change the cos squared x in terms of sine. Let me make cos squared x the subject. Cos squared x is equal to 1 minus sine squared x. But we are here plus. This is where we use our definition. This is just a concept now. So what does it mean? It means I'm going to automatically to transform cos power 3x in terms of cos squared. Because the principle demands that we must use Pythagoras theorem, which is the power 2. So I'm going to transform the integral of cos power 3x in terms of cos squared x, cos x dx. This cos power 2, cos power 1 gives us back to cos power 3x. But from Pythagoras theorem, cos squared x is equal to 1 minus sine squared x from our Pythagoras theorem. Pythagoras is now helping us to substitute for cos squared x in terms of sine. So cos squared x is equal to 1 minus sine squared x times cos x times our dx. What does the x mean? The x means we are respecting the x. So whatever is not x is here will not be respected. So I'm taking back to identify a function and a derivative. And this time we said for cos and sine, it is very easy to identify what is a derivative, what is a function. What do we do? The one trig ratio which owns the highest power becomes the function. The one which has the least power is the derivative. So I'll go back and try to recognize that this is a square of x and this equals x, which means sin x has the highest power and is my function. Cos x has the least power, is a derivative. And from the beginning of this topic, I was claiming that the moment you identify a function and a derivative, then you concentrate more on the function and you ignore the derivative. Why? A derivative comes from a function. So you cannot concentrate on the son and leave what? The father. The father has it all. If you want information, get it from the father, not the son. And therefore, first after identifying that the sign is our function, we shall try to ignore what? The derivative. And concentrate on the function which is sin x. So our rating must go in for the function. And I'm saying let us have this letter be equal to the function. And what is it? It's sin x. Why is sin x? Sin x has the highest power. So it's the function. So what is substituted for is the function, not the derivative. So the our u will equal to sin x. And therefore go ahead to differentiate the u the x. The u into the x. Which means we are differentiating sin x. And differentiating sin x from past principles, we get cos x. Differentiating sin x, we get cos x. Go ahead to make it dx the same. So our dx here is equal to the x is equal to the u over cos x. Then you are going to substitute for the x and for the function in the main equation, which is basically we substitute for the function and the respective only. Don't look at the derivative. It is a minor. It is derived from the function. So we are now looking at the main things, not the result, not the derivative. So this is the minor. Ignore what? We only substitute for the function and the respect. That means this is equal to integral 1 minus my sin x is equal to u. So it is going to be u squared. So it's done. Cos x is a derivative. Duplicate it as it is. Then remember the x we have it. The x is equal to du over cos x. Du over cos x. And since the derivative basically is useless, it is cancelling out. That's why you ignore the derivative, because we are aware also that the final derivative will come out of the function and it's going to cancel out along the way. So cannot attract our attention, because the final it is leaving us and we are continuing with the function which is 1 minus what? U squared du. Plus integrating 1 gives us back to u. Integrating u squared is u power 3. And we have a 5 u power 3 plus a constant. Then you have to recall what was u. formulating is sine x. So without wasting much time, you substitute for u. And that gives us finally also that this means the integral of cos power 3x dx is equal to u, which is what? Sine x minus a third sine power 3x plus c. If you can give us that answer, then it means you have integrated an even power of cos x, which is power 4. And therefore, the integral of this is equal to that. Plus this. Don't forget the c, because that is a constant, which caters for the missing limits of the lower limit and the upper limit. And we shall have cases where we have the limits. We shall never include c. We shall be having these examples with the given limits. So this is the integral of x cos power 3x dx. That's the answer. Next, we are going to move to higher powers now. Higher powers, like sine power 5, this is the power 3. So this is now, this power 5 is also an odd power. So suppose it was sine power 5, or if it was cos power 5, how do we go about it? But we are still claiming that the power 5 is an odd number. Therefore, we address that particular question using the same principle. So long as you are integrating an odd power, the principle is very, very simple. We use Pythagoras theorem. And since power 5 is an odd power, then we are going to employ the same principle to handle so we take u to cos power 5 x. Yes, this is power 5. But being an odd power, the same principle is going to hold. Pythagoras theorem. What does it mean? That I must condense power 5 to power 2, which means cos power 2x, cos power 2x, cos x. If one creates these powers members, you get power 2. The same base, we add the powers 2 plus 2 plus 1 back to the given expression. Why are we condensing power 2? Our Pythagoras theorem is in terms of power 2. So we change cos power 2 in terms of Pythagoras, which is now 1 minus cos x dx. So now this becomes our principal division that we're using. So take a note that again we have a product of cos x and sin squared x. Cos x and sin squared x. And for cos and sin, the one with the highest power becomes the function. The one with the least power becomes the derivative. So cos has power 1, sin is power 2. So sin is our function. Derivative. This is a function. After identifying which one is the derivative and the function, we now concentrate more on the function. And even at the derivative, after all, the derivative is derived from the function. So it means I will take on my sin, since it's a function, and forget about what the cause, since the derivative. So I'll let any value of my own case, like u, equal to the function which is what? Then you try to differentiate. This gives us the u, the x. And derivative of sine from first principles, you have it. You can actually write it in other ones. Differentiating u, it gives us cos x. Differentiating sine x, you get cos x, which you have from first principles. And therefore, we make the x the subject. We make our the x the subject. And we make the x the subject from a simple arithmetic. You end up with what? The u divided by cos x. Then we substitute, don't forget, when you are substituting, you normally substitute the leading equation, which we are playing after applying Pythagoras theorem, that becomes the leading equation. So start 2 is our leading equation. And you only substitute for the function and the derivative and the respect which is the x. The derivative is always a minor, so always zero on the derivative. It gets from the function. So we only substitute for the function and the respect. So that gives us the integral of 1 minus. What is the minus sign in x? For migrating, outside the x has u. But it is squared. That means we are going to store our u give us 1 minus u squared. But this again is squared. But cos x was a derivative, we ignore also. Go for the x which we have here as u divided by cos x. Cos x cannot survive because, as I said, it's a derivative. The derivative cannot survive at this level. Finally, we are ending up with only what? 1 minus u squared. Squared du. At this level, you can expand this using any means, whether it's identity, okay? When you just expand it, locally you get so you get the same answer. And at the end of the demands that when you explain this one, you're going to have an integral, okay? This is going to be 1 minus you double this, which is what? 2 squared. You square this, which is u power 4. Du. But assuming you don't have this identity, then expand it. Locally, just have the integral 1 minus u squared into 1 minus u squared du. Then you start multiplying 1 and 2. 1 times 1 you get what? You get 1. 1 times u squared is negative u squared. Negative u squared times 1, negative u squared. Negative u squared times negative u squared is positive u power 4. These are the terms 1 minus 2u squared plus u power 4. You get the same answer. So either way, you get it right. So long as you are steady. So long as you are steady, this one, you always get that answer. Then from that point, now we are here. That is the integral. We are integrating 1 minus 2u squared plus u power 4 du. Can you look at the integral of 1? What do we get? That gives us u. That gives us u. Integrate u squared. With the power by 1 becomes u power 3 over the raised the power, which is automatically 2 out of 3 u power 3 plus integrate u power 4 with the power by 1 over the raised the power, which is 1 over 5 the power 5 plus a constant. But remember, at the beginning, the setting was in terms of x. This here was just a rating. So you must take it back to, so it must be in the same format like at the beginning. So you have to you or minus sign what? Sign x. So there is u means sign x. So this is u. So minus sign x. And as 2 out of 3 sine power 3x plus 1 over 5 sine power 5 x plus c. And that is our answer. So if you want to conclude, you can have a conclude and say, therefore, the integral of cos power 5 x in x is equal to this. That will provide a conclusion. Just conclude by making therefore the integral of cos 5 x in x is equal to this. So remaining with only one derivation, which is sine power 5. And that one is done. Don't look at sine power 7, don't look at sine power 9. Those are higher powers and they are beyond this level, beyond the A level. We stop at 5 for all the powers. For even powers, we stop at 4. So you can see that even this example, that's to understand, because you don't go for power 7, you don't look at power 7 or 9. That's just at university. And if you have to look at them, we don't use this method. We use another called deduction method, which is under further calculation. That's why we shall be stopping at power 5 as far as this level is concerned. So you have only one derivation, which is remaining, and that is sine power 5. And so now we have got the concept. Since we have got the concept, I'm sure you can even handle that one now. You can handle that. Sometimes you can explain, you can also be writing what. Then you can just look at the answers. I'll be very fast, so you can just look at the answers, because now you have the idea. We're evaluating sine power 5x in x. The same idea. What's the idea? Using Pythagoras theorem, which means I'm going to condense it to sine squared x, sine squared x, sine x. Why are we condensing it? Pythagoras is power 2. And therefore, this means integral of sine power 4x, sine x. I can just have this sine squared, then square. That means this one means sine squared x, then square this sine x. Pythagoras will give us this answer very fast. Pythagoras. Sine squared x means 1 minus cos squared x. So this is going to give us 1 minus cos squared x. But squared sine x dx. This is Pythagoras theorem. And remember now we are back to the product of cos and sine. And we are claiming so long as there is a product of sine and cos, we just identify which one has the highest power. Cos automatically owns the highest power. So cos becomes a function. What there is the main, which is the same now. So our rating must go in for the function equal to cos x. Don't look at the power. In the power 1, because finally our concern is what? The dimension, the function. So the power will help us just to identify which one is the boss, which one is the minor. So this one is the boss because of the highest power. And therefore, cos x is our function. Differentiate du over the x. Then you have this answer. You get negative what? Sin x. Make it x be subject. Our dx is equal to negative du over sin x. We substitute for only the derivative and the function. So we have now an integral of 1 minus. We have the function as u. So this becomes u squared. Again squared. Sin x is the derivative. Just you know what? You have the x negative. So we have the negative, but that negative, you can pull that negative out of the integral sign. This now becomes u over sin x. The derivative cancels out. This regards to the negative integral 1 minus u squared du. And from our previous example, an expression of this was very clear. Is the same as 1 minus 2u squared plus u power 4 du. And this sign means demands for flip integrate. To remove this sign, you must integrate, which is referred as partial integration. Integrate one in favor of what? Of this. So each part can be taken in favor of the other. Look at 1, look at 2u squared, look at what? U power 4. So by integrating 1, we shall get u. Integrating 2u power 2, the power is going to be raised by 1 to have 2 over 3 u power 3. Where is the power? What is the power? Plus, where is this power by 1? It's going to be u power 5 over the raised power which is 5. Add the constant c. Just recall what is your u. This is equals x. Now, since you have number a, okay? U is equals x, take it back at what? The configuration. So u is cos x and therefore this is negative. Cos x is my u minus 2 out of 3 cos power 3x minus 1 over 5 cos power 5x plus a constant. We are entering the negative, give us negative cos x. This becomes a plus out of 3 cos cubed x. This is a minus now, minus 1 over 5 cos power 5x plus a constant. The constant cannot be affected by the sign. After all, negative 2 and the positive 2 means it is a constant. So don't now start wondering why this is a plus and it wasn't. No. The constant here is independent of the sign. Whether you put negative 2 or not, if you look at negative 2 and the positive means the same thing, is a constant. And finally, this is the integrand of sin power 5x. Sin power 5x. So at the moment, there are so many numbers I'm going to handle in the back house too. And you have those 2 books. Okay? You have them. Back house 2. So this is still chapter 1, and you'll be looking at only, so the number I'm going to look at is the integration of all the powers, sin and cos. When you meet the shower, automatically shall be able to yourself to even powers. So you need to automatically download that backhouse too. On our net, the 2 books are there. And if you have a copy at home, just open chapter 1, backhouse 2, address yourself to only what? All the powers of sin and cos. And for those who are still downloading, I have some numbers here, some few numbers here. Make sure you have these numbers. I just have my my number. I know it's helping some of your colleagues. They are going to be very active in my class. Throughout the week, they have been sending numbers for marking. I will still give you my number. If you get any challenge, first get the number 0702 39 37 86. This one is on WhatsApp. Any challenge, you can handle outside the class. So for example, look at if I have sign cubed 2x, 3x, number 2. Try sign what? Power 5. 2x, 3x. Number 3, you can write for me series sign. Let me sign the cost. You can have cost cubed. But this time this is 4x, 3x. The number 4, which is our so the last number we're going to have, is suppose you have cost. Let us have cost here. Cost power 5 of 2x dx. How do you think about that? These are all odd powers, which means the same principle is going to work. And what's the principle? The principle is using Pythagoras theorem. And that's the main concept for today. When you are handling odd powers, use Pythagoras theorem, which was well explained at the beginning of this topic. So long as these are odd powers, it is a taboo to handle odd powers. What do you use? Pythagoras theorem. So today we are stopping here. When we meet inshallah, we shall address ourselves to even powers. But there we are handling odd powers only. Go and work out those numbers in Bartels 2, chapter 1. And for those who are still students, you can see also look at what? They have just 4 numbers. If you can handle this, then it means you have understood. If you get any challenge, the number is here. Just text, you can use in the means of what? Communication, but finally you get the feedback. So unless they cannot wait, I'll just wish you a nice day. And when we meet inshallah, shall try to look at even powers of sine and cos. But I just request you to get my number, because I'm marking most of your colleagues, so many of your colleagues, those who are very active, I know them, but can also become active in the class and benefit from this system. So, get that number. If you have any challenge, please let me know. Otherwise, assalamu alaikum.